Silver is still one of the most sought-after metals today, especially considering it is 19 times rarer than gold. Its remarkable properties make it highly valuable in various industries. Silver is the best electrical conductor, the best thermal conductor, and the most reflective of all metals. In an astonishing application, silver iodide has been used to influence weather patterns by inducing rainfall and even mitigating hurricanes. The search for silver begins with geologists conducting extensive surveys and analyses. They examine rock formations, soil samples, and structural patterns to identify areas with promising silver deposits. Advanced remote sensing technologies and satellite imagery help detect subsurface anomalies that could indicate the presence of silver-bearing ores. Once a potential deposit is located, exploratory drilling is carried out, and core samples are extracted for testing. Assay results determine the concentration of silver within the ore, providing crucial data on the viability of mining operations. If the assay results indicate a high silver content and the deposit is close to the surface, open pit mining may commence. This method involves removing layers of rock and soil to expose silver-rich ore. However, when silver veins run deeper underground, miners employ tunneling systems that extend over a kilometer into ancient geological layers, searching for the lustrous metal, whether extracted from open pits or deep underground. Silver-bearing rock must be fragmented using controlled blasting with explosives. Specialized drilling equipment creates blast holes, and precisely timed explosive charges break apart the ore, while minimizing unnecessary debris. Once fractured, the ore is hauled to the surface for processing. The first step involves primary crushing, where jaw crushers reduce large chunks of rock into smaller fragments. These broken pieces are then sent to grinding mills, where heavy steel balls pulverize the ore into a fine powder. This grinding process liberates silver minerals from the surrounding rock, increasing their exposure for the next phase of extraction. The resulting powder has a surface area over 100 times greater than the original ore, allowing for more efficient separation. The finely ground silver ore is then introduced into specialized froth flotation tanks filled with water, air, and chemical reagents. As compressed air bubbles through the mixture, silver mineral grains adhere to the air-water interfaces due to hydrophobic properties. The resulting froth, now enriched with silver, is skimmed from the surface and collected. Additional separation methods, such as gravity concentration, using jigs and spiral separators, may be employed to further increase silver purity. These combined processes transform raw ore into a concentrated silver product that is transported for smelting and refining. However, over 90% of the original mined material is discarded as tailings, containing only trace amounts of silver. The concentrated silver ore is then fed into high-temperature smelting furnaces, reaching over 1,200 degrees Celsius to extract the silver from its mineral matrix. During this process, flux materials are added to help separate silver from iron sulfides and other impurities. As the molten material settles, slag, a waste byproduct containing unwanted elements, is skimmed away, leaving behind a semi-pure silver-gold alloy known as doré. This alloy typically consists of 70 to 90% silver and 10 to 20% gold. The doré alloy undergoes further refining to achieve the highest levels of purity. The semi-pure metal is first cast into ingots or bars before being transported to specialized refineries. To purify the silver, fluxing agents collect residual impurities, which are removed through heating and oxidation reactions. The next step, cupellation, involves absorbing remaining base metals like copper using bone ash or magnesium oxide. Finally, electrolytic refining is carried out, using controlled electrical currents to separate silver from gold, based on their electrode potential differences. Additional purification techniques, such as acid leaching or chlorination, may also be used to ensure the silver reaches 99.9% purity. The final product is pure silver bullion, ready for use in various industries. Silver's exceptional conductive, reflective, and antibacterial properties make it indispensable in modern technology. It is widely used in electronics, from smartphones and computers to solar panels and medical devices. Silver is also crucial in dentistry, pharmaceuticals, food preservation, and hygiene products. Its high reflectivity makes it a key material in space technology and precision optics. Silver has played a vital role in human civilization for over 6,000 years, dating back to the earliest days of metallurgy. It was once a primary form of currency and continues to drive cutting-edge innovations today. More patents reference silver than any other metal, highlighting its significance in scientific and technological advancements. From ancient economies to modern industries, silver remains a shining symbol of human progress, continuously unveiling new possibilities in the natural world.